Hello everyone, I am Savan Bhakti Prakash from TY Electrical, roll number 13. I am going to do the MATLAB simulation of the thyristor or SCR. This all the requirements are in simulation. So this is power guy. Without this we can't find any output or we can't define any output in MATLAB simulation. These components are taken from the library browser like this. Here is the one example like AC voltage source. So this AC voltage source is we are going to use or by double tap on the screen we can take. Okay, this is AC voltage source having frequency 50 Hz and peak amplitude 100 volt. Okay, this is pulse generator having the time period 0.02 seconds and phase delay 0.00166 seconds. Okay, this is main component of our simulation, that is thyristor. This is current measurement. Series RLC load means purely resistive load. This is voltage measurement and these are the four scope means our four output or four graph. Now okay, we are going to make the connections of this. This AC voltage source is connected to the series RLC load. Means negative side of the AC voltage source is connected to series RLC load. Positive side is connected to thyristor. Pulse generator is connected to thyristor. Current measurement also connected. Now here this voltage measurement is connected. Okay. Now these are the four scope. This is all done. The voltage measurement is connected across AC voltage source like this. Okay, the all connections are done. Okay, now thyristor is connected to scope 1. Current measurement is connected to scope 2. Voltage measurement is scope 3 and this voltage measurement is connected to 4 number scope. Now okay, the all connections are done. Now run. Now we can see the graph.
Hello everyone, my name is Gagrita Nishka from TY Electrical, roll number 22. Today I am going to explain you the VI characteristics of NPN bipolar transistor, that is BJT, and let's start with our CI activity of power electronics. So as you can see, I have taken all the components from library browser and then let's start with our connections. This is current source. This is DC current source, NPN bipolar transistor, current sensor, PS simulink converter, XY graph, ramp, simulink PS converter, control voltage source, electrical reference, and solver configuration. Now, so let's start the connections. Positive terminal of DC current source to NPN bipolar transistor. Then this terminal to current sensor to voltage or current voltage control voltage source, and again from control voltage source to the end of NPN bipolar transistor. Then DC current source is attached to control voltage source and the ground is attached to electrical reference. So now PS simulink converter and then control voltage source to simulink PS converter. Both the terminals are attached to XY graph. This is attached to RAM, sorry, and the XY graph to this terminal. So from this PS signaling converter, we are gonna get IC, that is controlled current, and from signaling PS converter, It is voltage source. Voltage current source. Okay. So now the ratings. DC current source is a constant voltage, constant current, and it is of 0.6 ampere. And then RAM, it is slope of 4 to minus 5. And then speed, stop time of the simulation, it is 10 seconds. We wanna run it. Let's see on. So this is our graph. Here, as we have given the slope, here, as you can see, this is our graph. Okay, thank you.
Hello everyone, I am S7, roll number 15 from TY Electrical, and I am doing the simulation on power diode. These are all the element blocks we required. Simply we take it from library browser. We required one power guide, one RAM function, one control voltage source, one diode, then multimeter, one DMUX, bus selector, and series RLC branch and scope. So click on the RAM function, and we required its slope 1, and start time is 0 and initial output is 0. Then click on the power guide. We required simulation type discrete. Then click on the control voltage source. Its source type is DC and we require to measure its voltage. Then click on the diode and we required its resistance is 0.001 and forward voltage is 0.8 and its number resistance is 500 ohms. And its number capacitance is 250E9. Then click on the RLC branch. These are the RLC branch, but we required R branch type, its branch type R. Then we required its 10 ohm, resistance is 10 ohm, and we want to measure its branch voltage. So simply we connect the RAM to the control voltage source, and control voltage source is connected to the diode. Then diode is connected to the series RLC branch, and voltage source is connected to the series RLC branch. Then connect diode to the bus selector. Then connect multimeter to the DMUX and connect DMUX to the scope. First terminal is connected first, then second is connected to the output. Then connect the bus selector to the scope. Then run it. Simply we get this output. These are the forward bias graph all. Then click on ramp function and change its slope 1 to -1 for reverse biased. Then run it again. Then we get the output in reverse bias.
Hello everyone, my name is Sanket Ange, roll number 16 from TY Electrical. My topic is MOSFET simulation for VI characteristics. So to do this simulation, we need first N-channel MOSFET, then current sensor, then control voltage source, then two scopes, one ramp generator, one ramp signal generator, one simulating PS, and one reverse simulating PS. Then we will require one DC voltage source and ground to generate the input voltage and the continuous power guide to run the simulation smoothly. Firstly, we will connect the positive of the voltage source to the N channel of the MOSFET, then the D portion of the N channel MOSFET to the positive terminal of controlled current source. Then the S channel of the MOSFET is connected to the negative of controlled voltage source. Then the negative of the DC voltage source is connected to the ground. Then okay, then the positive of controlled current source is connected to the positive of the controlled voltage source. Then the negative I point of a current source is connected to the Simulink model. Then the Simulink model's output is given to the scope. Then okay, the main negative terminal of the controlled voltage source is connected to the reverse Simulink generator, and the output of that reverse Simulink generator is input of the reverse Simulink generator is connected to the ramp signal generator. Then the scope is connected across this terminal to capture the output signal. And this configuration solver is connected across the negative of the DC voltage source. So this is all about the simulation. So to run the simulation, we will need to put the timer to the 1 second stop timer. Then we will run the simulation. So we will check the output. This is the ramp signal from 0 to 6 volt, and this is the constant output voltage.